Hello everybody. In this video we're going to do some practice with our recently developed idea of the cross product. So I've given you two vectors, u and v, and I want for you to find for me the cross product u cross with vector v. Go ahead, find this first. Well, if you remember from our first video, the cross product of two vectors you could rewrite as the determinant. And once again, if that word is unknown to you, just hold on a minute because we're going to explain determinants in a later series. But as for right now, we're going to just deal with this definition. I apologize. We're going to write the entries of u in the first row, -2, 1. All I'm doing is just copying these down into here. Then I would write v in the next one, 3, 1, -2. All right, so now we can begin our cross product. So remember, I would place my finger over the first column and block out, I'm doing it right now on my screen, block out the first column, and I would find the product of -2 times another -2. Remember, all I'm doing is the product right here. -2 times another -2. And I could put another parentheses around here just to be more neat. And I'm going to subtract from that the product we get from over here, which is just 1 times 1. But I'm going to color code it just so you know where it's coming from. That's just 1 times another 1. And close this parentheses. And what do we multiply this by? We multiply this by the unit vector in the column that we just covered with our finger, which is just I hat. And I'm going to subtract next from this. I'm going to put this below it actually because I'm going to run out of room. Minus. Now I'm going to cover the column containing j hat. I'm doing it right now on my screen. Cover the column with your finger containing j hat. Next, we're going to take the product of the entries in on this corner or on this part over here and this one, 1 and -2. And we're going to put another parentheses just to stay neat. That would be 1 times a -2. A -2 minus, now I go the opposite way, and that would be 1 times 3. 1 multiplied by a 3. And what did I cover up again? I covered up j hat. So I'm going to multiply this by the vector j hat. And similarly, now I would just cover up the last row. I'd cover up k hat, and I take the product 1 times 1. And I can't erase this. I apologize. Just the way this software works. But now I add. These are one of the few things that you have to memorize. But if you remember just how to do this, you can get any cross product that you want. So now I would get 1 multiplied by 1. 1 multiplied by 1. Minus, and now 3 multiplied by our -2 times 3. -2 multiplied by 3. And now I covered up k hat initially, so I would have to multiply this product by, this difference, sorry, by k hat. And now I can actually math this out, if that's a word. This would be 4 minus 1 gives me a 3 I hat. This would give me minus, so don't forget this minus sign. So -2, let's keep this parentheses like this for now. -2 minus 3, which gives me a -5, but times a minus, so bring this minus over here, it gives me a +5 j hat. And this one over here now gives me +1 minus -6 gives me a +7 k hat. And this right here would be our cross product. This would be our answer. So our next problem is to find the angle theta. I'll write this over here. Just find theta between U and V. U and V. Go ahead, try and find that angle theta. Well, if you remember from the other definition of the cross product, I told you that the magnitude of this vector here, magnitude of U crossed with V, I think I'm going to stick to one color just for now because this is taking a little while, would be the magnitude of, magnitude of U times the magnitude of V times the sine, not the cosine. The cosine is the dot product, times the sine of the angle between them. So I would just have to divide the magnitude of the cross product by the product of the magnitudes of U and V, and then take the arc sine of that. Well, that's probably going to take a lot of space to do, so I'm going to erase this up here. Good. All right. Now I'm going to find the magnitudes of U and the magnitude of V real quick. Magnitude of U, well, that's nothing more than just 1 squared plus negative 2 squared is a 4 plus 1 squared. This would give me the square root of 6. And similarly, the magnitude of V would be given by 9, which is just 3 squared, plus 1 plus 4. And this would give me square root of 14. And now the magnitude of U crossed with V, that's nothing more than just the magnitude of this vector down here. And this has a magnitude of the square root. 3 squared is a 9, plus 25, plus 7 squared is a 49. 9 plus 25 is a 34. This should give me 83, square root of 83. Just double check that real quick. 9 plus 25, 49, 83. We got it. Square root of 83. And notice, all I have to do now is I would just have to get magnitude of U crossed with V divided by the product of the magnitudes of each vector. Magnitude of V is equal to sine theta. So now I put this in the numerator, square root of 83 divided by the square root of 6 times the square root of 14, and that's going to give me sine theta. Well, I don't want sine theta, I want theta. So I would have to take the arc sine, or this inverse sine, of this quantity, and that would give me the angle theta. So let me get my TI-84 out, and I'm working in degree mode, but you can work in radian mode if you want. And I would get that the arc sine of the square root of 83 over the product square root of 6 and 14, that would give me an angle of about 83.7360 degrees. This would be the angle between the vectors, close to perpendicular. And remember, if they were perpendicular, their dot product would be 0, but their cross product would not be 0. In fact, their cross product will be maximized because sine theta would be 1. Now the next practice problem I want you to try is to take the dot product of this vector U crossed with V and U, and then take the dot product of U crossed with V and see what answer you get, and see if it's kind of surprising. I don't think it should be that surprising to you. Well, if you take the dot product, let me just erase this to get some more room. If you were to go ahead and take that dot product between these vectors, you would obtain, let's see here, let me erase this here. Let's do, first we're going to do u dotted with the vector u cross v. And let's do that. Remember how to take the dot product is to just sum the products of the x components added to the product of the y components added to the z product of the z components. So this would be 1 times 3, right? 1 times 3 plus negative 2 times 5. That's a negative 2. Let me rewrite that to be a little more neat. Times 5 plus 1 times 7. And let's math this out. We get 3 minus 10 plus 7. This is going to be a minus 7 plus a 7. We get a dot product of 0. And according to what we showed a couple of videos ago, if the dot product is 0, that means that u and u cross v must be orthogonal. And this is expected because we know that the vector that we get from the cross product is orthogonal to the plane containing u and v. So it must be orthogonal to both vectors u and v. Now, if we were to actually replace this, if we were to instead take the dot product with vector v, that would just be, I'm going to do this really fast, 9 plus 5, which is 14, minus 2 times 7, which is 14. 14 minus 14 is a 0. So we both get a dot product of 0 when we take the dot product of u cross v with u and with v. And once again, this shouldn't be that surprising because we showed this in the last video, but still, it's just a really cool, it's a pretty neat way to check your answer each time you take a cross product. Just dot it with the vectors that you crossed to obtain that vector with. So that's basic practice. We did a quick little problem. We found the angle between two vectors, and once again we showed you a way to check your answer. Take the dot product of the two vectors that you crossed with the cross product that you obtained, cross product vector. So I hope this was helpful. I'll catch you in the next video.